All right, welcome back to video 2 for day or Monday. You just finished the inquiry portion of this class. So talking about Chargaff's rule, thinking about what the relationship between adenine, thymine, guanine, and cytosine. And so now that you've had a chance to think about it, I'm going to give you some more facts to really strengthen that understanding about what Edwin Chargaff figured out about DNA, and specifically the nitrogenous bases. What you are going to need is you are going to need your notebook, you're going to need a pencil or a pen, and you need your curiosity. Sorry, that was the last one sparky, but I just want to make sure you're all there. Please make sure you're pausing me as we go to take these notes down. So just a quick thing, a podcast recap. You listened to that podcast, which I really enjoyed, but you heard really about 4 different people and their contributions to DNA, the model we know now, the one we recognize, and all their contributions. So just to quickly recap, Watson and Crick, this picture is pretty famous. They were the ones who get all the credit for discovering the shape of DNA, this double helix, basically like a twisted ladder shape. However, they would not have their model without this woman in the middle named Rosalind Franklin. Rosalind Franklin was the first to take a picture of DNA, and the only reason they figured out the shape was because of her photograph. Because she's a woman, she frequently gets left out of the conversation, but I want to make sure you know who she is. Edwin Chargaff, this man on your right-hand side, he discovered the rule that we're going to talk about today, which is conveniently named Chargaff's rule. All right, so bunch of different organisms. The question is, what do all these organisms have in common? We have bacteria, tiger, we have this adorable little child, which happens to be me, and a fish. What do they all have in common? And I wish I could take hands, but I can't. But what they all have in common is they're all made of cells. And they're all made of cells that contain DNA. And while all of us, we all look very different. A fish, and I wish I was more like a fish, but we don't look alike. But what's surprising is that what's in our DNA is very similar. And so some DNA notes, make sure you're taking these down. The macromolecule for DNA is nucleic acid, one of our 4 macromolecules. Nucleic acids are made up of nucleic acids are made up of the monomer nucleotide. And so one nucleotide is what's in this square. It's 1 nitrogenous base, 1 sugar, and 1 phosphate group. You don't need to remember all that. You just need to know that a nucleotide is made up of these 3 components. The nitrogenous bases are what we're going to focus on today. When I say nitrogenous base, the nitrogenous bases, when they're all put together and hooked up into our DNA, they create a code. And that code is why I have brown hair. It's why I have brown eyes. It's because the sequence tells my cells to make brown pigment for my hair or brown pigment for my eyes. And the nitrogenous bases can be adenine, which is represented by an A, thymine, or by a T, guanine by a G, and cytosine with a C. The interesting thing is that all organisms, so the fish, the tiger, me, the bacteria, all of us have those same 4 letters. We all have A, T, C, and G. However, we just have different amounts. So I might have 3,000 A's while a fish has 2,000 A's. The 1,000 difference is what makes me, me, and makes a fish a fish. And so it's really interesting to think about that. The very little difference between living things. And so that's DNA. As we get into Chargaff discovered something interesting. He figured out that there's a base pairing rule. And I bet you've already figured this out from the inquiry part of the lesson. And you notice that if there are 20 adenines, or A, there's going to be 20 thymines. And when there's 50 guanines, there's 50 cytosines. So Chargaff figured out that there's this 1-to-1 ratio. For every cytosine, you have the same amount of guanine. And for the same amount of adenine, you have the same amount of thymine. And so what he figured out was that C always bonds with G and A always bonds with T in DNA, and that's going to come into a later play. But I need to make sure that you copy this down, because you need to know the base pairing rule is C equals G and A equals T. And so this was Chargaff's contribution to DNA. So what I want you to do now is I want you to pause me. Press that space button, pause me. And I want you to answer this question in your notebook. What is the other strand of DNA? So write the initial strand, ATTGCT, ATTGGC. And I want you to write the complementary strand. What does A always match with? What does T always match with? So do that now. Now I want you to check your work. Notice how adenine always binds with thymine. T always matches with A. G's and C's and C's and G's. It doesn't matter which side's on which. A is always going to match with T and C is always going to match with G. Now, sometimes we talk about the amount of adenine or guanine or cytosine in percentages. And so we know that there's 100% total. So if we know that adenine makes up 15% of our DNA, well, if adenine's 15%, then cytosine is also 15%. And if I take 100 and I take away 15 for adenine and 15 for thymine, so that's 30% deduction, so 100 minus 30, I'm left with 70%. C and G has to be available in equal amounts. Because I know it's equal amounts, I can just divide 70% divided by 2, which gives me 35% for cytosine and 35% for guanine. Think about it as a whole. 100% whole, take away what you know, adenine and thymine, divide whatever you have left by 2. It's always going to be the same. And so now you are going to try it with this question. Write it in your notebook. If 20% of DNA strand is made up of thymine, what percent is guanine? And then if you know what guanine is, what is adenine and thymine? Again, write this in your notebook, pause me. Sorry, just kidding. And check your answers. So previously, 20% thymine, 20% thymine. We know that adenine is also 20%. 100, 20 plus 20 is 40, so 100 minus 40 is 60. We divide 60 by 2, and we're left with 30% cytosine and 30% guanine. If you want more practice, I'll post more practice up there too. So what you're going to do now is go back to the worksheet, complete section 3, part 3, the apply your understanding questions, remembering this Chargaff's rule. And then once you're done with that, make sure you complete your exit ticket on Schoology. I'll be on Zoom. If you have questions, please reach out. All right, stay awesome, stay safe. Talk to you later.